Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 29, Types of Chemical Reactions, Part 4. Here are our objectives for today's video. Pause here. So if I haven't done this already, I've probably posted to Google Classroom a PDF of just solubility rules. So these are a set of guidelines. They are determined through experimental evidence that are used to predict if something is going to be soluble in room temperature water or not. This is useful if you want to know if something's going to dissolve in water or not, because the chemical properties in the solution versus the solid are totally different. So you might want to know before you do an experiment if something's likely to dissolve in water. For the 10HH class, I don't make you memorize them. AP is a different story, but that's a problem for a future you, potentially. Pause here. Okay, I'm just going to work through these. These are pretty straightforward. AgNO3, I look at my solubility rules. All nitrates are soluble with no exceptions, so that is soluble. AgCl. I go down the list, I find that Cl is mostly soluble, but Ag is an exception. So instead of being soluble, it is going to be insoluble. Na2NO3, that should just say NaNO3 actually, but either way, it works. NO3 is always soluble with no exceptions. Na is soluble with no exceptions, so that is going to be soluble. And then CaCO3. Okay, I see carbonates are mostly insoluble. Calcium is not on the list of exceptions, so this is going to be insoluble. Pause here. So a really common type of reaction is what's called a double replacement reaction, which is just when I have two different things, two different salts that are dissolved in water. Both of them are totally aqueous on their own, but because when they're dissolved in water, they're actually dissociated, they're able to interact with one another, and potentially the cation from one of those and the anion from the other can form a solid. The solids of form are called precipitates. So this video, we're really going to be concerned with those types of reactions. Pause here. Right, so when we are writing double replacement reaction, you pretty much always go through these 4 steps. You write out the reactants, so you're going to need to remember your nomenclature, how to write the formulas. You're going to swap partners, so I'll elaborate on that during the example. You're going to be balancing the equation just like you normally would, and then you determine, using solubility rules, if a solid forms or not. The reason why we care to do something like this is because oftentimes you'll be in a lab and you'll mix 2 things together and all of a sudden a solid will form, and sometimes students will freak out and say, why is there a solid forming? They bring it to me and I'm like, oh, that's no big deal. It's just some calcium carbonate. And you're like, how did you know that? Well, this is how I knew that. Pause here. Okay, I'm going to work through this one with you. So first step, I'm going to write out the formulas for the reactant. I've got silver 1 nitrate. And they're going to be aqueous. You can check with the solubility rules if you want, but I assure you I'm not going to purposely try to trick you. Okay. Next, I'm going to re-crisscross to get my product. So Ag has a +1 charge, chlorine has a -1 charge. So I've got AgCl. I'm going to fill in those brackets a little bit later on. And then I've got calcium with a 2+ charge and nitrate with a -1 charge. My next step is I'm going to balance my equation. So I need to have a 2 here and a 2 here for everything to be balanced. Then I go to my solubility rules. I see that chlorine is mostly soluble, but silver is an exception, so that's going to be solid. And then nitrate is soluble with no exception, so that is going to be aqueous, and I am done. Pause here. So spectator ions, so they're called spectator ions because they're not really participating in the reaction. So the ions that are not forming the solid, so they're aqueous on both sides, are spectator ions. Pause here. And then for the net ionic equation, we just remove the spectator ions. So I have the example that was there before, the one we solved, or actually, no, I don't. That's just a very similar example. The net ionic equation is just what happens when I remove the spectator ions. So when I remove the spectator ions, it's no longer AgNO3, it's just Ag+. If I remove the Na+, I'm left with Cl-. I could have put the Cl minus before the Ag. I just prefer to put the positives before the negatives. But that being said, of course, you could have swapped them and it would have been equally correct. Pause here. So I've already written out the molecular equation. So the spectator ions, I look and I see that calcium is aqueous on both sides, but it's a spectator ion, so I do need to list the charge. And then NO3 nitrate is aqueous on both sides. And that leads me to the net ionic equation, which is really just going to be the formation of AgCl. You can think of this as sort of like the reverse of the dissociation reaction. And that is all I have for you tonight. Thank you so much for watching and have a good night.